Okay, should be live. Uh, um, Welcome back, everyone. I've been looking forward to this stream because I've been wanting to do this for for a very long time. So, this stream is about Mailbox, and so a bit of background. When the Apples M1 and M2 and all of those SoCs, they have a lot of coprocessors, as you know. And a mailbox is how the coprocessors communicate with the main CPU. A mailbox is a very simple thing. It's a little piece of hardware where you can send a message, and the message is usually just, one word, 64 bits. And then the other CPU receives it, and you can do it in both directions, and it's a very, very, very common thing. So I'll switch to the code screen, actually, and show you a bit of what's going on. So this is the driver we have for the Apple Mailbox hardware. And Sven wrote this way back, and we've fixed a few things since then. Hasn't really changed that much since we wrote it, and it's about 470 lines of code, which isn't that much. So what's the problem here? The problem here is that we are using a shared subsystem that Linux has for Mailbox hardware. So we're using a common abstraction. And the idea is that, no matter what Mailbox you have, you can write a driver for it, and then the other side, whatever driver needs to actually use the Mailbox, talks to it with a standard interface, and it's all nice, right? Well, kind of. So the thing about subsystems like this one and abstractions is that they, there's a few reasons why you want to do that, right? One is that if you have something like I2C or SPI or USB or a serial port or, basically any kind of standard interface, then if you have a common abstraction, that means that you can put together any two drivers from different sides, right? So you can have any USB driver talk to any USB host controller, and they use the same interface. So you don't have to have, several versions of a USB Ethernet driver, depending on which USB host controller you have, or different, like your driver for a I2C codec chip doesn't care about what I2C host your machine has. And that makes perfect sense. That's not the case for Mailbox, because Mailbox is not a standard. Mailbox is just an idea. There is no, de facto or de jure standard for mailboxes whatsoever. All Mailbox hardware is different in some way. Some have more features, some have fewer features. Well, it looks like I got a package. The size of the messages is not fixed. Some hardware can do queuing, some can't. There might be one channel, there might be more than one channel. There is no uniformity. So that doesn't work. When you have a Mailbox client and a Mailbox provider, they will almost certainly always go together. There is very little room for a Mailbox consumer, like a driver for some coprocessor, to support having multiple types of Mailbox behind it that are from different vendors or that, were not originally intended to be that way. It is common to have multiple, variations on Mailbox hardware, and we have that here in Apple. We have two variations. There's the M3 and the ASC Mailbox. It is common to have, one vendor having different kinds of mailboxes and then possibly the same driver on top. That's fine. But there is no real case where you would have, like, a driver that has nothing to do with Apple on top of this Apple Mailbox driver. It just doesn't happen. The only hypothetical case for that would be if you have, like, open source firmware running on the coprocessor and then an open source driver on the CPU, and then you want to port this whole arrangement to different platforms with different Mailbox types and then share the code and, like, share the drivers. But even then, you'd have to deal with the, message size possibly being different, and like that just doesn't happen. And even if, it does happen, it definitely is not the case for Apple. So yeah, that doesn't make sense. Okay, so why else would you use an abstraction, a common subsystem? Another reason is because the common subsystem implements useful code, useful features, like shared functionality that different drivers can use, and then they can share that, and that's all good. And that works as long as that common code base is actually well written. So it's particularly useful when you have things that are easy to do wrong, and it's easy to do them wrong, and you don't want every driver author to reinvent that wheel and do it wrong, or just because it's a lot of code or something. So that is sort of true for the Mailbox subsystem. What it mainly does is it implements queuing. And that makes a lot of sense for single message mailboxes, which are very common. It doesn't make any sense for us because these mailboxes have their own queue. And on top of that, the Mailbox subsystem's queue implementation is so well designed that it has a fixed size across all drivers. You cannot change it. And if you try to send more messages that then fit in the queue, instead of just waiting and blocking until the queue becomes empty or some space becomes freed up, it just returns an error, which means that it is actually impossible to block on the queue becoming available because you'd have to pull. So that's great. So yes, the Mailbox implementation's logic might be useful for other mailbox types. It uses, I think it uses a K-thread or a work queue or something. It, sends stuff in a different thread. It does the queuing thing. It has some extra logic for some stuff. It has mutexes. That doesn't make any sense for us because the hardware, as I said, does the queuing for us. But on top of that, mailboxes are usually used for hardware like system controllers, little things that send a few messages, per second at most. You might get it for some I/O devices, but those often have their own mailbox drivers that don't use the Mailbox subsystem. On Apple Silicon, this Mailbox driver is on the hot path for submitting work from the GPU and getting back completion notifications from the GPU, which means that you do not want to do useless stuff in, the path from GPU driver wants to tell the GPU to do something to that actually getting to the GPU driver. And as I said, the Mailbox subsystem implements a queuing system and basically requires a context switch to actually send stuff out to the mailbox. So that's also really dumb. For us, and then as I said, because it implements its own queuing, but it also has no notion of hardware queuing, we can't use our own hardware queuing. So right now we are blocking on every single message we send before we send another one through the Mailbox subsystem for no reason at all, other than the Mailbox subsystem doesn't support that. So we could send up to 16 messages at a time, and we just can't. And the other issue is that the Mailbox subsystem supports multiple channels when you have more than one mailbox. What we actually have is multiple endpoints, which is kind of part of the message, which is how we implement it here. But that also just doesn't map well. And then we have this extra concept of a channel that there's only one per controller. So we are just, adding in one extra layer of complexity for no reason. And then, of course, we might want to add features that this Mailbox subsystem doesn't support. So one is that for some cases, like the GPU, we might want to deduplicate messages that we send. So we might say you can put a message in the transmit FIFO, but we can keep track of what has been sent. And then if you try to send the same message again, if we can determine that the FIFO is still full and it already has that message in the FIFO and the other side hasn't received it yet, then we can just not send it. And that works for some kinds of drivers like the GPU driver. And that means we can actually guarantee that we never block on messages into the GPU mailbox because the way that driver works is it only has to send doorbells, and there's a fixed, I think it's actually even just only, Alina knows more about that. I think it's like 3 channels and 4 priorities. It's like 12, basically, plus like a couple extra ones. So less than 16, which means that even if you are pending all possible doorbells, that would fit in the FIFO. And so by definition, if we implement that, there will never be any blocking, which is great. We can't do that with the Mailbox subsystem. Doesn't support that. We could cheat, maybe, like we can make some of these things work with the Mailbox subsystem, but we'd be working around the Mailbox subsystem. And this has been an ongoing problem with this driver. We need to be able to send messages and receive messages in atomic context. The Mailbox subsystem has a way of doing this. It is inconsistently implemented and implemented differently by different drivers. It's also very confusing and probably buggy. We are currently seeing some issues with reboots not working on the latest kernel rebase. I don't know if this is the cause. I would not be surprised at all if this is the cause. So I figured now's the time to do this. And if it fixes it, great. If it doesn't fix it, it'll be easier to debug that way anyway. So that's another issue. And yeah, it just doesn't make any sense. So what I'm going to do is I'm going to copy this driver into the Apple sock tree, which is where we have our Apple-specific drivers that don't fit in any other subsystem. And then we are going to remove the usage of the Mailbox subsystem. And the other side of this driver, the consumer, is RTKit, which is already in the Apple sock subsystem. So then we just have to make that talk the new API we are going to make up. And then we're going to try it, and we're going to make sure it works. And then we're going to see how much faster the GPU is with that. Because I'm pretty sure it's going to be faster. And I also hope it's faster, because that'll be a very good argument for why we're doing this. I am going to write a long email when we submit this, explaining why this was a bad idea, and we need to move it into SOC and just give up on Mailbox. But if I can also say, oh, by the way, that this benchmark is 20% faster now, that's a good way of convincing people. So, with that in mind, I want to first take a benchmark. And I think I need a fork of GLMark 2 for this. Or at least a version that's not in the release. Because there was... I know the Arch Linux GLMark build does not have basically displayless support. And I need one that does. I think it might be in master now. Yeah, DVM is okay. I probably just need to clone it and compile it then, and I don't need any special branch, maybe. So what I'm going to be testing on is an M2, just because I have it lying around. And right now that has the Mesa package that we are considering releasing. So this is not released to Asahi Linux yet, but the idea is that once all this stuff works and we think it's good enough, it's going to be released very, very soon. And so that should have that Mesa that works. And I just booted a random kernel bird from my local branch. That's fine. And so git Asahi git, I'm going to have to clone GLMark. I think that should have what I need. So we're going to take a baseline. I know Lena at some point got like 9,000 FPS on some of the faster benchmarks and on M1 Mini. I would hope the M2 is faster, but we'll see because a lot of things have changed anyway. Also, I'm not sure if this kernel build does it have debugging? If it does, I might need to do a full... Oh, it does. Okay, damn it. Okay, I'll have to turn that off. And that means a full rebuild, so this is going to take a while. That one I'm probably going to keep. But let's not turn on lock debugging. And why is this one getting selected? Is it this? No. Oh, that was okay, yeah. Yeah, so let's turn off lock dep. Do a build without lock dep. I don't think there's going to be any risk of locking related bugs in this driver because it's like it just reads and writes registers. We're going to have a spin lock and it's going to be very obvious, basically. The whole thing is super simple, so it's pretty hard to get wrong. So I don't think we're going to have to, look at really really deep stuff here. So that should be fine. I don't know if I don't think we care about that. Turn off logs. Probably don't care about that. Yeah, let's just turn off all this stuff because I want a fast kernel to and turn off tracing. I want a fast kernel so that we can get some benchmark numbers. And Rust hacking. You know what? Let's turn off overflow checks. I'm going to leave that one. Actually, no, I'm not. We don't need that either. Not for this. Make sure nothing else is in here. Memory debugging. That should be a cheap one. That one we can probably turn off. Okay. And that means a full rebuild. Whoops, I forgot I might have locked dep on, so that's going to take a while. So while that runs, let's start messing with the driver. So Linux drivers sock Apple. I'm going to copy mailbox Apple mailbox.c in here. I'm just going to call it mailbox.c because Apple is redundant. And I'm going to edit the kconfigs. Mailbox kconfig. This shouldn't be a very long stream because honestly, I don't think this is going to take that long to make work. There's pretty little room for screwing things up from this driver. This is very simple. And it's going to be even simpler when we drop this. Unfortunately, the module is called Apple Mailbox. We're going to want to keep the name. I was wondering if we wanted to actually make it a separate module or just bundle it into RT-Kit, but we probably actually do because it's going to be used by SAP eventually. And it's already a separate device in the device tree. We definitely want to change the bindings. So I think I'm going to do it the right way and basically keep all the current structure. It's just that it's not going to use the mailbox subsystem anymore. It's just going to use something we make up. So with that in mind, I'm not going to actually delete that kconfig. Because also we need to make sure that when we upstream this, the whole thing is not going to break something. Problem is I want to use the same config. If this had been like mailbox Apple, that would have been nice, but no, this is not going to be Rust. There's no the RT-Kit is the consumer for this. It's written in C. Maybe this will be written in Rust someday, but it doesn't make any sense now. So yeah. Maybe we can just call this Mbox. And so then the RT-Kit stuff here, which depends on Mailbox and it depends on Mailbox, but it doesn't depend on Apple Mailbox. Yeah, so we changed that. Depends on not Apple Mailbox. Actually, no, we just say depends on Apple Mailbox. Going to create that on top. Box. Mailboxes. We do want PM for that, probably. We don't need any of that. Default Arch Apple, yes. I don't think we need ARM64 here. We might need 64-bit. Because that should compile test on any 64-bit Arch. And this can be tri-state. And then RTKit depends on Apple Inbox. And this one, Apple Inbox, depends on not Apple Mailbox. And then I probably want to drop the default here, because otherwise it's going to end up with a weird order of things. Because I'm not sure what happens with defaults if there's multiple like conflicting ones like that. Actually, no, I think it's probably fine, because then you'd probably just not have the default. It might work, yeah. I'm not sure. Okay. So we're going to call it that. And so then here's the mailbox code. So we have this shared Apple Mailbox H file. We also need to copy that. That can just stay in driver's sock, because we don't need anything outside this directory to care about the mailbox right now. And the SCP driver is probably going to be here anyway. So this is just... You have any other header files here I can use? RTKit internal. Yeah, so it's going to just say Apple Mailbox H. And I don't even know why we have... We're not supposed to have copyright years here anyway. And here's where you're going to have the actual interface. So let's look at the interface first. RTKit.c, how's the build going? Actually, I'll break everything. Why do I have two consoles open? It's supposed to be this one. Okay, I did build. Let me just run that. Why do I have two consoles open? Let's move that in here. Wait, that's the wrong... I'm confusing myself again. Yes. No, wait. No, I'm not. Yeah, okay. Yes, console there. Run... not the hypervisor. Let's just run it without anything, because it's going to be faster that way. And this is a J413. Get some firmware on there. That should be fine. So I'm not going to get the console on that, but that's fine. And so we'll see what kind of performance we get. Is it going to connect before? Yes. This is using Mason. I think that works or not. Jesus, Mason.daughter. Okay. And then I need the flavors or whatever. Flavors. GBM Glass V2, I guess. Let's get both. Actually, let's also just do DRM in case we want that at some point. Okay. Build source GLMark2 ES2 GBM, I think is the one I want to use. And then I need to give it the data path. And let's just run it with default. That looks right. $7,000. Okay, yeah, I need the there's always the CPU performance thing. Lee always also does this. The devices system CPU freak policy for scaling governor, and then do it like that. Because the CPU scheduler is still a bit wonky. It's another thing. We were talking about that on IRC the other day, that maybe Mesa should automatically. Okay, 8,300 FPS. That looks okay-ish. Let's let it run for a bit and see if we can pick. Because I want like the highest FPS, because this is going to be looking at driver overhead effectively. So the cheaper the test, the better for seeing what the differences are. Looks like 8,500 is about where this is at. Oh, 700 on shading, Gorod. That's interesting. I would have expected the build ones to be faster, but again, the GPU firmware, I think. Also, I have like a next session here. Actually, yeah, let's turn that off. Let's turn off SDDM. See if that's any faster. Nah, it's about the same. Maybe a bit faster. Okay, well, so we'll call that the baseline, 8,300 something, 8,500 something. So I'm going to do, while we work on the driver, I'm actually just going to run this in a loop. And this is going to be log mailbox, log baseline. We're just going to let that go in a loop forever, and then we can get some statistics out of it. So making this work, we need an actual API for this. So what RTKit is doing is mailbox. Yeah, I have Apple inbox message. That's fine. We can keep that. RTKit internal. Yeah, so we're going to just say mailbox.h for that. We can put that here. So instead of map inbox client and all that nonsense, what we need is, that's an internal too. We don't need mailbox anymore, mailbox client. Inbox name, inbox index. Yeah, so this will be Apple inbox. Inbox, no channel, because that goes away. And so we need a struct for that. And so then in RTKit RX, yeah, so this gets set like as an RX callback and stuff like that. I don't even know if I want to use the container off thing, but I guess we'll keep it similar for now. Apple and that's inbox. Just inbox. And in this case, obviously, this is going to have the right message. And drop that. Oh, did I miss the append? No, I had the append. I have the Asahi. So this TX done stuff, I don't think any driver uses this. And the only reason we have those completions was to free the messages, which is an artifact of the mailbox driver needing that. And I don't think we use that for anything. It's just message completion. And then how is that done? Ticket wait, ticket free. Yeah, if it has a completion, it completes it, frees it. I think there's nothing that waits on that. Okay, yeah, so send message takes a completion. Does anything use this? I don't think so. Because that completion is basically useless anyway. Because you don't care about when the coprocessor receives the message. You care about when it processes it, which this isn't going to tell you. So I think nothing uses that. So we have... ticket, SMC, yeah, I'm pretty sure. Yeah, DCP doesn't use, nothing uses this. What other, do I have any other drivers using RTKit right now? NVMe doesn't actually send anything. I think that's it. And in fact, the Rust bindings probably Yeah, okay, nothing uses that. That is going away. So no need for completions, which means we drop that. And then we don't even need to alloc the message here. All of this is basically useless. We don't need atomic because that is only used for the allocation, which we don't care about. And then send message. Wait, wasn't this supposed to use a different message send function if it's in atomic context? Maybe that's why reboots sometimes don't work. I don't know. Drop that. Apple inbox send, wait for message, RTK inbox. That should be, if it's not a pointer, it should be a. And then that doesn't need to be a pointer because it's fits in registers, is fine. What does completion do? Actually, it's just a signal that you can wait on. So it's just so that you can get notified when the message is actually sent. But there's no use case for that for us, because we don't care about when messages are sent. We care about when they are processed, and that doesn't tell you that. So nothing uses that. I don't think anything's ever going to use that. So once this is all gone through, I'll probably just have a cleaned up patch at some point that drops that struct completion, and we'll just go with that. So yeah, it should be fine. And there's no k-free anymore, so just return that straight from there. So already simplifying things. And then poll is used for the weird like synchronous API, which makes sense in atomic context. Let's call that Apple inbox poll. Give it the RTK. And then the receive callback, there's no TX done anymore. That goes away entirely. Couldn't the WMB be moved to the mailbox send? Yeah, it could be. But the mailbox itself doesn't care about DMA, so it's kind of a question of taste where you put it. Hypothetically, you could have a driver that doesn't need DMA, and then, in fact, SMC doesn't always need DMA, so we could elide that, but it's kind of a technicality anyway. Our ticket RX inbox message and no pointer on that. We'll just take it as a inline. It's probably going to be faster. Work message 0. There's a question here about what happens if this allocation fails, which isn't great. But I'm not sure if we can really fix that. Short of like having some pushback thing. We can't peek messages from the mailbox as far as I know. So it's basically a notification that is not used by anything and probably shouldn't have existed in the first place. And the only reason this driver needed to keep track of the structure anyway was because of the mailbox subsystem issue, where we have to keep like pointers to messages, which is very silly because the message is 96 bits. That you don't why are we allocating 96 bits of memory to pass around messages? It doesn't make any sense. The only reason for that is that the Mailbox subsystem is generic, so it has to handle any message size, so it can't be part of the structures and the prototypes and everything. But once you don't have that, it can, it's just data. There's no need to allocate memory for that. I think that's pretty much it. And then just the actual initialization here. So in init, inbox name, inbox index, and then we just where's that? What does request inbox chan do? That just does this and then start. Yeah, because I added that start chan. That's another thing, right? So this is another problem with the Mailbox system that I think I haven't upstreamed yet. Long bits. There's just so many problems. Yeah, this one, defer, Lena wrote this one. Defer mailbox channel start on the right. So basically the problem is that when you start a mailbox, it's going to start receiving messages as soon as, as you do that. And this RTKit might not be ready to do that yet. What was the exact patch? Yeah, so there's a defer startup thing, right? Actually, I thought there was another thing there. Oh yeah, it was a thing in the mailbox, right? So the issue is that you can already have things coming into the mailbox, and then the mailbox subsystem itself dies because it's trying to receive data into a channel that hasn't been created yet. The whole thing is just broken, okay? So, yeah. You seem very frustrated with upstream kernel patches. Have any upstream experiences mean smooth for you? Yes. No. Sometimes it's fine. I have some people that I upstream stuff to, and I know they're not gonna, frustrate me. In general, ARM64 stuff, interrupt controller, SOC, because SOC I am upstream. So nobody tells me anything. But there's been other random stuff. Honestly, it's just there's so many things. You remember the bad stuff, right? I know Povik hasn't had trouble with audio as far as I know. Oh, what else was there that I did? CPU Freak was a bit annoying due to a lot of going, around different solutions. I don't know. It's also that I tend to pick the annoying ones and let the other developers handle the less annoying ones. Outside the kernel, KWin and stuff is fine, yeah. I don't particularly remember any weirdness with NVMe either. I think that was fine. Honestly, the best one is probably being the interrupt stuff with Maz, because I get along with Maz really well, and we just, it's not the main thing I work on, but when I do, it's like, we just throw stuff at each other, and all the conversations are, all the nitpicking is useful nitpicking, right? Like, things we actually need to think about. So, yeah. Yeah, that's the other thing, is I am upstream for this change because I am moving Mailbox into SOC, right? So ultimately, they can't stop me from merging this. They can only stop me from deleting the old driver. But I mean, if they want to keep around dead code, that's... I think Sven mentioned that the Mailbox maintainer, that he originally wrote support for Mailbox FIFOs, and the maintainer didn't like it. And so that's why you're not using it yet. So and I also wrote one fix up for the polling stuff, and he also didn't like it. I was actually cleaning up other Mailbox drivers that were using the APIs inconsistently, and he also didn't like it. It's just like, it's just so much stuff. So anyway, where does the actual Mailbox client get set up here? Oh, is it just... Wait, where was that done? Now I'm kind of lost. Request mailbox chan. And there's a re-init on that for some reason. Oh, because it does by name. Okay, so this does the whole thing, yeah. Yeah, so yes. And there's a free channel and free. Why is there a re-init in that path? That might be a bug. I don't know why we request the mailbox chan again. Oh, we free it, okay. Oh, okay, this is another hack, right? It's so that we don't handle any messages while, yeah. Stuff like this. So what we actually want here is if I have mailbox main, red equals apple inbox init. Actually, apple inbox. So this is another thing: is whether we want to have more than one consumer. If so, we want to keep the mailbox channel. It's not a channel anymore. Because like it's a different device than the device tree, right? But there's only ever going to be one consumer for these mailboxes by definition. So maybe it doesn't even make sense to actually do the binding like that. And then it also means we can get rid of all the power management because it would be subsumed by the owning device. I think that actually makes a lot of sense. Yeah, honestly, it's someone's going to complain about me doing it that way, but it's just simpler if we don't even do that. Then we can drop all this OF match stuff and everything. And then we can use devm for... And then you can use devm and then it just goes away when this goes away. We can make things so much simpler. If you run into any very unreliable S-QRT buses in your history, don't work when lower the S-QRT clock. I haven't seen that, but that makes some sense because I think some devices have timeouts. But yeah, I2C can... We have some I2C problems. I2C can get very, very weird. Okay, yeah, so you know what? We're going to get rid of the mailbox hardware driver story. And this is going to be... This is going to be less code if I do it like that. So, yeah. And then we can use devm, which we also have RTKit stuff for devm here. Yeah. Devm apple inbox init. by name, RTK inbox. And then we don't even need to keep the mailbox name anymore because we are only calling it once. Less code, less code, less code. So that never has to reinit anymore. If inbox name else that equals init inbox index. And then we drop all this stuff. Well, and then we are just going to pass the Rx function straight here. Because that's all that has to go into inbox. And it's RTK, not RTC. And we don't care about any of that because we're going to have explicit start functions. Just call that inbox start. And we don't need, oh, this has to go to free RTK there. Do you think Apple should open source everything? No, because I don't want to see their code. It's not going to be pretty. Then we just call that. And we just call start. I think that is most of it. No free channel because dev-m is going to, well, I might not want to use dev-m for that. Yeah, I don't want to use that dev-m because RTKit itself is wrapped by. Okay, let's drop the dev-m. And I would need a dev device there anyway if I use that. I do need to pass the dev device though because it needs to look that up. And I can actually just set this on the structure. Not pass it as an argument, because then we can also use this for options if we want to add options in the future. Can even be done after init, because we're not starting the mailbox yet, so it's fine to have an initialized Rx function. And I can just go here. So that's about what we need for the API. And then the make sure we stop it in the free path. And actually, we can just use free, which should implicitly stop it. Let's call it shutdown. Hello from Australia. Love you got Asahi booted in my M2 MacBook Pro 2020. Nice. Wait, M2 2020? I think you mean 2022. Well, I've got it on a MacBook Air here I'm testing on. Okay, so that's about right for the API. So let's actually write down this API now. Apple Inbox. So we need the device on that. Do we even need the device on that? No, it's the init is going to look it up, so we don't need the device on that. We do need the receive callback. So the actual prototype for that is that. So the actual APIs. Apple Inbox stop. Start. Stop should probably be void. I don't think that can fail. Apple Inbox shutdown. Should be void because there's no way for that to fail. Inbox init by name and init. Vev. Take the name and the index one just takes an int index. Init, shutdown, start, stop, and send. And that just sends a message. And why is there no atomic? I thought we had... I think that's a bug, and that might be why reboot is broken. Like maybe a patch got dropped somewhere that added that. Send atomic. Actually, no, just... Hello. We want the next device on that. That's pretty much it. I don't think there's much more API than this. Oh, and we need poll, yeah. Start, stop, poll, inbox. And we do have a return value from that. I don't know if we use that. I think it was supposed to return whether messages were processed. So that probably is useful. I am replacing the I am excising the Mailbox subsystem from our Mailbox driver and just implementing it directly. Okay, so let's see if RTKit compiles at least. It could be two separate functions, but the thing is the contents are going to be the same. It's just the difference is going to be whether it blocks by blocking on an interrupt or just busy waits for the queue to be free. So, because we're going to use a spin lock in both cases anyway. So I think it makes sense as an argument. Should be shorter code eventually. So device drivers, sock. Well, first let's turn off Mailbox. Mailbox hardware support. Apple Mailbox driver. Nope. And then where is the sock stuff? Apple. Yes, so now we have Apple sock mailboxes, our ticket, and the helper. That one is new. And I'm sure that's going to fail to compile on the mailbox code itself, but at least almost. Oh, we had two MSGs. Wait, what? Wait. Oh, because... Oh, yeah, that goes away, our ticket message. And then that means that can also go away because... Where is that? That's also less code. Don't need that anymore. And some unused variables and some mixed declarations because we are still in the 90s. We can just put that at the top here. Flags and red are actually gone, so that's easy enough. Okay, that compiles. So there's our API. Now we implement it. I'm going to put the header file on the right and this on the left. Is this actually compiling right now? I think it might just be compiling and being the mailbox driver, right? Yeah, it is. So it compiles, but it's the wrong thing because that is going to go away. And then we just include box an H, drop the controller, and then we don't need PM runtime because I can just use the stop and start. And we can even use that when RTKit gets through the shutdown stuff. Probably don't need GFP because why would we alloc anything? There's nothing to alloc. We do need platform device, OF. Do we need platform device? No, because this isn't a device anymore. It's just going to be looking up stuff in OF. Do need interrupts. I'm going to fix the copyright line while I'm here. Yeah, so ranks, hardware, this is basically going to be the same, except we're going to move it into mailbox.h because this is what the driver needs. We do need the locks. See, we have the locks on the driver already, right? Because we needed that because the mailbox subsystem doesn't handle the locking properly. There is not going to be a controller. We don't need the device for anything anymore there, I'm pretty sure. We obviously don't need a channel. RQ send empty. So what we actually want is the send... not full. And I'm not sure if that actually makes sense. Either we are missing interrupt bits or something is silly here, because what we actually want is, unless empty means space and FIFO. Let me do a quick test with Mini. And I guess we get to kill Jailmark now. So a mailbox that should be not running right now, but hopefully active. I think the NVMe should qualify. Is that what it was? Was it ARM sock? Wait, am I just confused now? Sock? No. ARM IO, sorry. Is it ANDs? Yes. ANDs should have registers. Forget which one it was. I think it's this one. That looks about right. I think it's an offset like 8,000 or something. And these are 32 bits for the control registers. Okay, that's 0, so... Control full, control empty. No, I probably have this wrong. Maybe it's this one. Should just look at our device tree instead of guessing things here. Okay, that's it. That is a mailbox, and we have the... this is 110, so it's AP to IOP. It's the send path, which is what we want. And that claims to have the empty bit as 1. Actually, let me look at the mini stuff, because we might even just have better docs in the mailbox stuff here. How will this work with AV, which don't run our ticket but still have M3 mailboxes? Same thing. The mailbox code here would just be called by something else. Might have to move the header file somewhere else, but... Okay, so this, yeah. We have the control has enable, it's enabled, empty full overflow FIFO count. And then... But we don't have the interrupts here because we never use interrupts in Mini, so that's... Okay, so let's see what happens here. That's what the... control one is, and then what about the interrupts? Oh, right, no, the regular mailbox just has discrete interrupts, and it's the M3 one that has the extra ones. Yeah, we're getting send and receive. Receive not empty, send empty. Yeah, okay, so which ones are the numbers for this one? I'll just look at the device trees for that. Apple drivers, no, Linux. Arch, ARM64, boot, DTS, Apple, T8112. So this one is the the ANS mailbox, and they're actually using the 8000 one, so I'll go with that. And it claims it's interrupts 717, 719, 719, and 720. Isn't this backwards? It should probably be send.full or something. Receive.empty makes sense. Send.empty doesn't make sense. I'm not sure. Let's see what we get. So where is AIC? And this is an AAC2. I need to figure out the offsets for that. I keep wanting to have a proper wrapper for that. What was the offset of that? I know it was like it's probably just easier to read it. C00. Looks like this one. Yeah, it should be 6800. And so then the interrupts we want are 717. To 720. Yep, that's conveniently all in the same word, which is X16. And the base for that is this. Okay. And then we want the ones starting at D. Spin. Okay, so right now the send empty and received empty interrupts are firing, which makes sense. The thing is, if there is no explicit interrupt for send not full, then there should be some kind of threshold control instead. So let's see if we can find that. So first, let's send a message. And that should be at inbox 0, I think. Well, the names actually make more sense in this one. A to I, send 0, yep. We write 64. Random message, and then we write 32 on the next. And the coprocessor should be dead right now, so that should now give us... Nope. Still says it's... Would it be alive now? No, ANS should be shut down. Maybe I picked the... Let's try a different mailbox. One that I know is shut down. DCP should be running. Let's just use the GPU. We know that needs startup. What was that called? That. And the registers for that are... at 206408. Okay, that looks right. So let's try sending a message. No. That really should be shut down. Why? Oh, is it because I'm writing 32 bits instead of 64 on the bottom? Oh, okay, yeah, okay. I was using the wrong write type. Okay, so now we have one message in the queue. And what are the interrupts for that? But now I'm going to go back to the other mailbox and see if... because I already have the interrupts for that one. Oh, but this one doesn't like it. Okay, maybe that is alive. Oh, wait, no, I messed up. That's not 64, 774. Yes, okay, that does work. So, yeah, bin. Okay, now it's 110. It was 101 before. So that has gone from send empty to send not empty. What I really want is a threshold interrupt. And that kind of tells me, because otherwise we can't actually really use the queuing, because we would be firing interrupts constantly. We don't get an interrupt until the send queue is empty, but then we want an interrupt when there's space in the send queue if we are sending something and blocking on it. That kind of tells me there has to be a threshold control somewhere. So let's dump all the registers. Not the actual... Yeah, there's a bunch of stuff there. And these are like messages, actually. This might be the FIFO or something. That's the one I just sent, actually. Okay, these ones sound like thresholds. Let's actually add this to the mon. I want to see when this changes. I don't want to read the actual mailbox registers, but I want to see everything else. Okay, those ended up as 0 now. So now, are those just on controls then? Yeah, okay, those are probably enables. Yeah, so that's actually the FIFO there. Actually, let me look at some hypervisor traces because macOS might be using some of this. I don't have any that actually have those registers. Oh, okay, I got the Outbox control ones. Maybe it's in here. Maybe it's in the control register. What bits can we set there? Oh, just that one bit. And it doesn't change that. Okay, so this one mailbox has a depth of 8, it looks like. I thought it was 16 for some reason. Wonder if there's different configurations for them. And that hasn't changed. And if I read the other side, which I think is there. No. It's just 8.8. Yeah, and then it drops to 7. Interestingly, that 5 there, that bit got set when it overflowed. But how do we clear that? Oh, it's here. Is it? No, that's the other side. Okay, we need more registers here. Oh, there's something there. Those could be thresholds. Oh no, those are sets and clears. Huh. Oh. And all the interrupts are set. It's weird, that's firing the empty interrupt. Okay, those don't do anything. So maybe these have to do with thresholds. Maybe it enables full queuing. So there's a bit 2 there. Then it claims TXMT. And then what if I actually put more stuff in the queue? Wrong place. Still claims empty, but now it's 7. Now it's full. Still claims empty. Okay, that doesn't make sense. Okay, so that's why this is 2 registers, because that's the receive side. That's the IOP side. We don't want to mess with that. Okay, now it's 110. So that bit does that. Setting that one, still 110. Setting that one, still 110. Setting that one, 111. Okay. So if I turn that off, now it's 0. And now let's pop something. Not that. Okay, 120, what is that? It's nothing on 110. Number 4. I think there's 2 mailboxes, and this is tweaking. Yeah, I think that changed that. I think there's 2 sets of interrupts, and that's why these are separate flags. What I don't understand is what that's doing. Okay, 1 second, I'm going to go to the toilet, and I'll be right back. Okay, back. So, come to think of it, there's probably separate thresholds for different things. So let's try just brute force. Again, didn't do anything. Let's mount the rest of it. Yes, and now we're popping stuff every time. That A there, what's that? Oh, there's stuff at 0, okay. Oh yeah, I forgot about that. Okay, there's some... It'd be nice to know what some of the other bits are that we are not recognizing here yet. So you have the full and empty bits. Know about those. And overflow is 18, and 19 might be underflow. I would like to know how to clear that, though. I mean, you're supposed to have a reset bit or something somewhere, right? For this kind of stuff. I wonder if it's writing to the mailbox that does that, like the upper bits, because we know the upper bits on receive are like the status. Nah, they just went to C. Nah. Hmm. Interesting thing is that these are like right pointers, which look like you would have almost like a 16 entry FIFO, but here it's actually 8. So this is like 2 queues with 8. Let me add more stuff there. There's stuff before here. There's more mailbox stuff there. Oh, this one has 16, I think. Oh, this is an alias or something. There's more stuff here somehow, though. Maybe there's like a compatibility view or something. No, but no. There's other messages. See, this kind of sucks because we set the mailbox at 8,000 already. But if it turns out we need to use the prior view, then then we have to change the DT binding, which kind of sucks. How did we end up with that anyway? This is already Python. Yeah. I think we might have just screwed it up by having those the offsets, quite possibly. The thing is, we know we have the ASC control. Like CPU control stuff is over here at the beginning. That's the CPU control stuff. So I think the mailbox stuff starts at 4,000. Yeah, because the first half is like possibly the IOP's view or something like that. But I'm trying to find threshold controls because it doesn't make any sense to have a FIFA without threshold controls. Okay, but then how do we use the FIFO? I mean, we can write stuff to it, but then if we need to block, we have to block until it's empty, and that's weird. Yeah, I mean, that's what I'll have to do otherwise, but it's kind of dumb. Okay, that just killed the interrupts, all of them. Okay, so that's actually interrupt enable, that one bit there. And then I don't know what the other last two things do. I guess we might have to just do that. Yeah, I get the feeling the other part is like the ASC side or something. It's not doing much. You have that stuff, but that just enables even more interrupts somehow. Yeah, but the 4,000 thing and the 8,000 thing are the same mailboxes, but then if you look at the actual dump, this stuff is the same, right? But then in 4,000, there's like more queue after that. And then the actual enables seem to be different. So it's like another view on the same mailboxes, somehow. Now, I think the FIFO is just there for debug purposes. Apple likes to do that kind of stuff. But what I really want is a threshold setting, which it doesn't look like we have, and that's kind of sad. FIFO is first in, first out. It's just a queue. And maybe there is no threshold setting. That seems like a really dumb omission, though. But it doesn't look like doing anything to the 4,000 side registers changes anything in the 8,000 side ones. I mean, these are clearly some kind of flags, like interrupt flags. But I don't know what interrupts they enable. The threshold depends on how much CPU you want to spend. You might want to put the threshold at 50% or at top -1 to keep it always full, or 50% to do it like in batches without it letting it run to 0. There's several ways of doing it. It looks like 4000 is just a view into more FIFOs. Like the first are the same as the 8000 ones, but then there's more after that, and also more flags. But it doesn't look like we have thresholds. I would love to know what those ones are, though, the ones after that. The 2 registers after the control registers. Because they don't seem to do anything. Okay, Sven says he didn't find any thresholds, so I guess there's no thresholds. I'm annoyed by those ones, though. I wonder what those ones do, but I'm not sure if it's going to be easy to find out. And then the first 2 are obviously some kind of extra flags. Maybe they're just software. Maybe they're just software interrupt flags. Like a sideband. Maybe it's just like so that even without a message, you can ping the other CPU on the empty or in full interrupts. So that feels like what it's doing. Like if I set a 2 there, then that's the which interrupt is that? That should be the empty interrupt. Wait, wasn't it empty? No, it's full right now. Yeah, so if I set a 2 there, the empty interrupt ends up high, even though it's obviously not empty. So maybe it's just software interrupts. That clears it, it's still the same. And then if I set... That doesn't do anything, though. Ah, but one of those did. Is it 20? Yeah, okay, so... That looks like just software interrupts. For some reason. Which means that should be the other one. Yeah. And then I don't know what the 8s do. Must be some other set of interrupt flags. I mean, normally you use the doorbells with the actual messages to signify stuff in RAM, but maybe that's just for testing or for something else. I don't know. Can we actually write to the FIFO directly? Probably not. Nah. Yes, I know I have a package. Try memset 64 just in case that does anything interesting. Looks like that ends up being a memset 32 with the top side cropped off or so. Actually, where did... Oh, no, it is full right now, that's why. Interesting, and then doing a memset on that did actually put some message into the other queue that we can't see. We're going to probably write but not read? Okay. And also, not having any way to clear the error flags doesn't make any sense. Oh, that did it. Okay, so the reset is in like the CPU region. Yeah, okay, so there's some reset stuff in the first page. Oh. Let me clear. Yeah, I guess there's no threshold. Wonder where the reset bit is. I know there's a reset bit. Somewhere there. Okay, it's after 800. Okay, so 800, I think that's like an interrupt controller thing or something. So maybe 808 is a reset for the mailbox. Yeah, that looks right. Yeah, okay, so 808 is a reset for the mailbox. And that might be the only way to clear the flags. That's kind of sad, but okay. Yeah, I think we don't have a threshold bits. I don't think we have threshold bits. So I guess the logic will just be what's vent had, which is what when the transmit FIFO gets full, we have to wait until it gets completely empty before we can queue anything else, which is kind of stupid, but that should usually never happen anyway. So it's not actually that bad. It just means there will be a blip where the interrupt has to be processed by the AP before we start filling that up again. But it's actually the best option for low CPU usage, for battery runtime. So it's probably fine. Okay. So that means we're using the existing everything. And then we just have to do what's been said. So we have some spin locks. From driver, inbox driver. So we're not doing that anymore because this isn't a driver anymore. We do want a device table, but it's not a module device. Is it a module device table? No, it's not, because this module is going to be a straight dependency of the others. So then we can actually just kind of put this at the top. Or put the init function at the bottom. A probe. Wouldn't be probe, would be init at this point, then we need to use those things. So let's actually implement this. Mailbox.h. Init by name and init. Did this one have dual license? Yeah, so it can just be export symbol. No GPU on that. Not that it matters anyway. Maybe we should just have a single function, to be honest. Because we're just going to call into the same code path. Oh, this is forward declared. Then we can leave it at the bottom and it's easier to see the diff. Okay. Node. Let me just get the node out of that. And then no alloc because we already have this allocated by the caller, so we just need to keep some stuff. Do we need to keep dev for anything? I think we don't. I think it's only used for like dev debug, which I think we can just not have the debugs there. Because honestly, if we're looking for transmit and receive, we're probably going to be running this on the hypervisor anyway, which tells us, so we can drop that. We do need regs, but it's not dev in platform anymore. Well, yes, but need to grab one from the OF. And this also has one other big advantage, though it's kind of somewhat accidental that it has it. Right now, if you build the kernel with modules and do a standard distro init ramfs, that mostly looks at things like block device drivers. It doesn't pick up the mailbox drivers. So a standard distro init ramfs does not work. By switching it to doing it like this, we're going to have a direct module dependency between like the storage driver at least, which means that like if you forget to include the special Asahi init ramfs stuff, your system will still boot, which is a very important thing. What do you mean by I'm not in Spain? What are you talking about? I'm in Japan. Okay, so I need to I need an IO remap. I need to get a resource out of this somehow. What was the right way of doing that? Also, it's struct device node, not, did I say OF node? It's struct device node is the right thing there. OF address to resources, I think what we want. Yeah, I think we might have had some Apple stuff using that, maybe not. So get the OF node. If ret, no put on that. And we need IO resource, but not platform. It's just the vem IO remap resource should do it. It's just a resource. I'm going to pretend I didn't see that message because I think Sven is listening but is on the other channel and not looking at YouTube chat, maybe. What does this return? Does this return... Where is that defined? Oh, in DevRes. Okay, this can return error pointers. So that's right. We take the hardware, RQ, receive not empty, so it's not platforming, or it's more like OF. Get by name. And then no controller nonsense, that's all going away. We just need to init the spin locks. And there's no runtime PM to be had. I think we just return 0 here. And we don't need a TX pending anymore. I think that was just a hack for the mailbox subsystem being silly. So what's that OF translate thing about? We don't care about that anymore. I think. No, we don't care about that. What we just need to do is do a p handle lookup ourselves in the caller for this. So it's Apple inbox init. Let's go to OF. And then the actual init functions here. Basically, OF parse p handle. And I need one for I think we do have the sales stuff done properly. Yeah, inbox sales. So init would be index, which is this one. So we need the args. OF node. Inboxes. Inbox sales. And the index, args, if ret, return ret. We need to OF node put args np. And so we need to do ret equals sample inbox init OF fev inbox node return ret. So that's the init one, and then I need the by name. Do we even use that anywhere? We have inbox names, okay. I need a... Is there by name anywhere here? Okay, the implementation of that should tell me. Yeah, that match string. Okay. That equals funky match string. OF node inbox names name. Right. Actually, just call it index. Return index. Return apple inbox init dev inbox index. And these aren't static, and they're exported. So that should be fine. And the next thing is that then we can also control these RQF no suspend flags and stuff, which might be part of why we're having some issues, actually. So we might want to control that later. I know there's some stuff that is broken. Okay, no ops, that's going away. And now the other stuff. So inbox stop, disable interrupt, that looks about right. Disable interrupt. Apple inbox, inbox, already not empty. Gets rid of that. Box stop, and then we do have no out to en. And then start is just going to enable that. And we do need the controls for that. And then this can just be void. There's nothing, there's no error case for this. So here's when you get to the nonsense mailbox stuff that's mostly going away. The expanding false ending sync. Yeah, this is the flush for sending stuff when in atomic mode or something. We don't care. I think this whole function can just go away. Yeah, so peak data is basically pull, which we already have. It's just that takes the RX lock. And it's the same as the receive function, so that's fine. It just depends on let's call that locked, and then we can just call this inbox pull. Oh, and that's a bool. I might as well just return red then. And that's not static anymore. Apple inbox pull. Inbox chat, so that's just Apple inbox again. And then this one is the locked function. And then we just go straight into inbox RX. And that only gets called from there, so you might as well inline that. Also, it just gets called for them. So we can inline all this stuff into pull. Well, I guess it would inline it anyway, but it's honestly easier to read if it's just the one function. Inbox control is read L relaxed. Inbox ranks. Inbox to a control. While not empty. Another read, and then we just read the messages. I dropped some yeah, let's go that way. Then send to empty IRQ is that one. So we're not going to do the... I guess we can do the queuing. It's just that send to empty IRQ should just fire the completion. And we can take that. We need an init completion. In here. Inbox txempty. Inbox poll. Inbox start. Inbox receive IRQ. Poll locked. Send empty IRQ. And what's the ordering here? We need to disable IRQ. Hold on. Let's make a spin lock. The spin lock is going to be released, so we don't. No, the spin lock is going to be held. Because otherwise we potentially get stuff out of order. Although that's not guaranteed anyway, so maybe that's okay. But it doesn't help to release. It doesn't make sense to release the spin lock because we're blocked anyway. But we need to release it so that the blocking can schedule. Yeah, so it'll just be fighting if there's more than one person trying to send. But the important part is that if we're waiting on this, the lock is not going to be taken. Yeah, we just need to take the lock. And then it doesn't matter what order we do things in because it's all locked anyway. And then there's no TX pending involved. Inbox send, we'll just call that inbox send, and then we don't need to care about that. Okay, and then Apple inbox send. This one takes a message. Atomic. So on send, we take a spin lock, IRQ save. We don't have to care about TX pending. And then we are actually going to look at the FIFO depth. And that is bits 20 to 23. what how do you call this? Let's call it count. The only thing I don't know is whether all of them have the same FIFO depth. Oh, actually, no. We can just look for the full bit, and we don't care about the FIFO depth. As long as the full bit goes away when it's... Yeah, just look for full. I need to count. Which we already have. And I can just inline that. What is empty used for? Nothing. Okay, so in send data, we take the spin lock, then you probably want a timeout on the completion anyway. Okay, so we do a do spin lock IRQ save, TX lock flags, read the control, read L relaxed. This is just going to be inbox, 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 control. If it's not full, break. Actually, you can probably just do it like that. So I'm not going to save there. Then we take the inbox control. Let's do that. And then do if actually just do while it's full. We enable the interrupt. No need to TX pending there. Yeah, so we enable the send empty interrupt, enable the interrupt on send empty. Unlock it. And then we need to wait completion. Probably doesn't need to be interruptible for this one. Just put a random timeout there. Honestly, this one should probably be not that high because if the firmware is dead, if firmware is running, it should get an interrupt and pop this pretty quickly. So if t is less than 0, return t. If t is 0, e time. Otherwise, we actually complete it. So we take the lock again, we update the inbox control, and that's fine. And then at this point, we can send. And again, I can just inline this because there's no point in rechecking can send. We just check that. Control full. So I can just do that. Not a pointer anymore. Message1, inbox, regs, inbox, send 1. There's not going to be any errors there. And then unlock, and that's it. Then return 0. Okay, you mess up any other comments? No, those look fine. All right, and then we can drop all this. And we drop the definition from here. And suddenly we have FIFOs. And that should be pretty much the whole driver. I need to replace a bunch of that with that. Should replace so and then do that. Actually, no, that's not what I want to do. And then that's an actual thing. Oh, and then the atomic. We need to check for the atomic. So that changes this code path. If atomic, else actually do the wait. Actually, I can just put something in a break in there. And then how do we pull? There's stuff. Redel pull timeout. That should be all I need. Address, values, condition, delay, microseconds, time, and microseconds. But we need atomic, I think. Yeah, we need atomic. Read L pull timeout atomic. What does that return? Just a return. And then the value is inbox control, and then break condition is not full. Delay microseconds. Honestly, the atomic path is only used for reboots, so we don't really care. Run delay timeout. That should be fine. And then that returns he timed out. I think he timed out is a better return for that anyway. If ret, return ret, otherwise break. Should fix other ones I forgot. What's the point of getting rid of the system? Because it is doing things we don't need. I explained it at the beginning of the stream. Just go back and watch it if you want to hear the story. I gave a whole explanation. Basically, it doesn't do anything useful for us, and it makes everything slower, and it makes everything more painful, and it makes everything harder to debug, and it doesn't make any sense. Common code isn't always a good idea. Okay. Inbox. I think that's pretty much it. I need to make sure. So poll is fine. It's just that the... Oh yeah, no, it's fine to call poll there because the RTGit stuff is going to call that directly, and then I think the user is just supposed to implement the timeout in that case, so that's fine. Do I want to skip spin lock on atomic? No, I do want the spin lock on atomic. But I do need to, yes, I do need to restore that. Thank you. Okay, let's see how much of this I broke. I probably need OFIRQ in here. Oh, interrupt device module. Yeah. Probably forgot some exports. No, actually, that looks fine. Pull locked, send MTIRQ. 394. How long was the original driver? It was longer. So, yeah, we dropped about 80 lines of code. Not bad. And now the question is it going to be faster? Did I drop? I think I dropped something there. Okay, not that many errors. Okay, inbox start is void, so we don't even care about that. And that also means that we get rid of that error path, because that can never fail. So even less lines of code. Driver sock Apple RT kit, Mailbox start, and then just put that in here. And then in Mailbox, implicit. Oh, I need IO poll or whatever that was called. I'm using a 5K AMAC, yes. And actually, I'm only using it at 4K right now because Linux doesn't support the weird special 5K mode. So it's not even that good of a... Okay, that needs to be Node. I'm using it because I got it because a friend was getting rid of it, basically. And it's a nice... I wanted a 4K monitor, which I didn't have before. So it's nice for 4K. Apple inbox init. That should not be static. And then node. No, that's fine at index. I just need a... That's just RxNP. No, that's not bad. That compiles. Apple inbox send. Did we not export that? Oh, it's send data. Okay, it's just send. What would it take to write the necessary parts of Linux to support 5K? It would take reverse engineering the weird thing Apple did with like the double display port stuff. Okay, I need shutdown. Yes, I need a shutdown function. And that's just deleting some stuff. So we stop the receive interrupt. Probably shouldn't be devm in this case. You use devm for these. I mean, it's fine, to be honest. Did the original even do any cleanup? I think we don't even have a... Yeah, because it's devm for the IRQs. Yeah, honestly, if we're using devm behind the scenes... The problem is that then we can't request it twice, so that's technically wrong. So then we can just drop the devms. Does that even need to keep the name? I guess it would. Yeah, devm sticks to the caller dev, and honestly, they probably shouldn't be re-initting the... There's no real use case for that, but yeah, I guess I'll get rid of that. At least the IO remap and the IO unmap inbox regs. So this needs to stop the inbox, and then we need to make sure nobody is... Well, if we're calling shutdown, the inbox has to be dead anyway. It can't be anyone sending stuff. So what's the opposite of request? Is dev ID IQ flags? It's just free IRQ. Do we need the data? Okay, that just calls the IRQ. Okay, it does want the cookie apparently, so. Which is just Mailbox in this case. On inbox stop, we should probably at least wait until the anyone blocking on sends is done. Oh, and I need a reinit completion there. For in here. And so I should probably just take the TX lock. So first we stop it so we don't receive anything. Does that make sense though? Because I think when you disable an IRQ, it guarantees that the handlers have finished running. And we should only send from that in atomic context. Which means it would poll anyway. I think there's no use case for that. Yeah, I think we don't actually need to do anything there. So then that only leaves the KS printfs, but I think we can just not care. Okay, what did I break now? I remap resource. We do have that, don't we? Or is it just IO remap? Yeah, so we have the MP stuff there we added, but there is a way to do this without devm. Isn't there a direct OFIO? Yeah, there's an OFIO remap we can just use. I think. Actually, RMP will tell me because that was the fix for that. Where did we put that? We put that into. So devres does it and OF address does it. I think we need the OF one. Map NP. Oh, it's OF IO map. Oh, that's what we want. We want an OF IO map. And then we just take a 0 there and we don't need any more. Okay, drop the resource, even fewer lines of code. Okay. And that's node, not dev. And request IRQ do not take dev anymore. Okay. And defend reference the bad U delay. Interesting. I guess it doesn't like... Wait, minus 100? How'd that happen? It's interesting that there's a compile time check for that. Okay. Let's see how badly I broke everything. And so first, let's run it in the hypervisor. So we get some nice logs. And if that works, then we'll do it bare metal and see what the performance is like. That looks fine, but it looks like it's working. Is it going to work on the first time? The first try? No way. DCP and everything is working. I mean, to be fair, the driver already worked. I just kind of deleted the brokenness. Well, that's interesting. I thought that only happened with Rust. Any reason why I don't dogfood my own distro yet? Because I need external monitor support. I do dogfood it in like my travel laptops and stuff, just not my dev one. Okay. So let's just try running that real quick. Interesting. That GPU log. I guess that happens on the first. Okay, I'm already seeing large numbers, and this is on the hypervisor. So let's reboot and get it bare metal. Yeah, I think that one expects the... Actually, I'm not sure. Well, reboot just worked. So that's the atomic path. If that worked, we're good. But I think that we do... when we do a poll here, the only caller for that is if the Mac SMC or something. Actually, it's in platform. Apple SMC RT kit. And then here, yeah, we just check for less than 0. And we don't even use the return value otherwise, so that's fine. So yes, it's fine. Yeah, I'm pretty sure it's the right driver because it's compiling it. And I changed this whole thing to use that driver, so I can't not use it. In fact, we can even disable Mailbox entirely. I think I did disable. Actually, we can just turn that off now. So we don't need that at all, but that's not going to change anything. And then there's one more feature that might be useful, though probably not for most of the DMARC tests, which is that deduplication thing I mentioned. That only matters when your depth of submissions is like greater than 8, which I don't know if it is for them. It might be for some of them. We can try it. The only trick is that we need we actually need to know the FIFO depth for that. And I don't know if that's actually the same for all of these mailboxes. So while that will require an audit of the hardware. Okay, so let's see what scores we got. T log new. Yeah, I would hope they describe it in the hardware rec somewhere, but I didn't see anything that looked like that. Of course, we could always just have it so that we only support deduplication when that property is provided in the device tree, and then for all device trees, it just doesn't do it. Yes, this is without Mailbox. 8333, 8566. Okay, so I know some of these are kind of random, but let's see what we were getting before. Look at the logs on that. Git DMARC. It's not looking very different right now. I think one of those was closer. So let's grep build on baseline. I think we might be a bit faster on average. Okay, I see more than 9,000 now. So yeah, I think we're faster. Not by a ton. I would have hoped for more, but still, it's still faster than Mailbox. Maybe. No, wait, 9,100. I think we're gonna need more than one run to figure out if it's like faster on average. Also, it might be faster for some of the tests more than others, because these are probably blocking on a single send anyway. Or like a couple of them. But there's some that probably queue more things and then end up blocking on them for a single render. So let's just look at what the total is, and then we can look at specific tests and see if like one of them in particular is faster. Okay, that one's faster. We never got above 8,700, and now we have like 900 on there. I think we are going to be faster on average. Okay, I'm going to let it run for a bit. I'll be right back. I'll just leave the screen on here. Okay. I get the feeling terrain might have gone faster. We're definitely faster in general. At least on this run for like almost all the tests. So I guess run it a few more times and see what the averages look like. And GeoMark isn't exactly the the most scientific test, but Shadow seems to have gotten way faster. Oh, actually, no, it was like faster and then slower. That's weird. There's some weird like variance where sometimes some things are faster, sometimes some things are slower. Anyway, we got 6855. Which is the fastest. That is the largest so far. So that's a good start. Not by a lot, though. Is there a chance our Q latency is going to hit the context switches on CPU idle state sleep? Yeah, so the IRQ controller doesn't currently have any affinity, especially on the M2. The M1 does. The M2 does not. And that could be part of the issue, like it ending up on the efficiency cores. But then the actual GLMark task should end up on the performance cores because I'm task setting it. But since the IRQs are processed by the other CPUs, I might want to set that to performance too, but then it would be unfair versus the previous test. So let's just go with this, which is the same setting as before anyway. So let's just let it run a couple GL marks like that. And actually, now that I finished the whole thing, let me look at one run. It's pretty close. The desktop effect shadow. Oh no, that's also very random. The 379. Yeah, it is the fastest so far, but yeah. So here's some of the faster ones. Yeah, none of the tests really have like an obvious jump. I'd have to actually like take the data. Let me just grab for all the tests here. So we had 8333 on that one. That's close to the fastest. 8566. That is faster than all the others, but not by much. Texture. 868989. Oh, we weren't getting 8.9s on this one. These got faster. Yeah. We had 8.4, 8.6, 8.5, like 8.6 on average. Now we're at 8.9. So that's, what, 5% faster? Then Gorod. Well, shading. Let's just look at all the shading ones. 9, 8.6, 8.7, 8.7. No, it's about the same. Then Bump. Those also got faster. They set like normals and height. Normals was at 8,400. Now already it's at 8,600 and 500 respectively. So some tests did consistently. I mean, assuming this isn't all slower the second time now, which it might be. Normals. Okay, we got 8,400 again, so I don't know. Have to do more tests. Effect 2D. Eight seven seven four. Also, this is a MacBook Air, so it is thermally limited. So it might be that we're just throttling at some point. Which is why I probably should just run this several times and see what happens. I wonder if those slowdowns are what happens when it throttles, like when it limits the max P state or something. That would kind of make sense. And then that's why you get like those runs, sort of. I want to say we got marginally larger because it was all 272 before and like 275 now. So yeah, I think it's slightly faster, and then there's a lot of noise. Like I never got a 6994 on ideas before. This one's a bit faster. I think it just has to run for a while and see what scores we get, and then we can just average out a bunch of them and call it a day. Okay, while that runs, let's do some git commits and figure out how you want to do this. So this has to go upstream before all the other junk. So this has to go on top of mainline. But we probably want this version on for Asahi. So we want this stuff. Is this formatted right? Yeah. That isn't, though. And then what's the right thing for sock again? It's just sock apple. What's the logs for that like? Just mailbox output looks like. Okay, that should work. And then I hopefully can put this on the mailbox tree for our version anyway. And then I just need to rebase this on the on the original stuff. Asahi whip. How did we end up with a... Oh, because doc channel is somewhere else. I'm going to put this on the top. Because otherwise it's going to be a conflict. And hopefully if I do it like that, it's not. And then RT-Kit has some change. What changed? Oh, that RT-Kit init is exported. And there's one more here. Because Linus patches aren't in this tree yet. That's fine, though, because this makes this closer to upstream. And then I just need to put the extra patches on top and fix the conflicts again. Where are those patches? Are those in GPU, I guess? Maybe? No? Are they MISC? Oh yeah, I guess they would be in MISC. Yeah, because there's a lot of RT-Kit stuff that happened there. Yeah, this one. And that's not going to merge cleanly, so we might as well put it here. Yeah, and then here the same thing. And then the other thing is, what was the other conflict? There were two conflicts. Oh, the other one was just the make file, I think. And then I just need to drop that one here. Let's see if it merges. Nope. Oh, because the helper also came after. Okay, I need to put Mailbox before RT-Kit. It's this one, actually. Does running mini writes or deletes anything on the hard drive? No. I mean, other than like having to install mini in the first place. Okay, that merges. And how's this going? I think it's faster. Looks faster on average. We'll have to look at specific tests. Let it run for a bit more. Actually, basically one more. And that'll be the same number of total runs, and then I can just average some stuff out and see what we get. Because last time it got warm around here, and if getting it warm is the issue, and it's when the score dropped a bit. So we'll see if that happens. Okay, now let's rebase this. I need a sock branch for that. And I want this on top of Torvalds. And I probably want that in RC1. And then look at the bits here. I cherry pick that. And of course we have some brokenness. Because, huh? Oh yeah, because this already has Linux patches on it. Because you haven't rebased yet the main tree is why. And yeah, that's the first startup thing, which we did get rid of. And again, that is already upstream. And then the read driver is just gonna complain about that, but and now if I diff against this, How do I get a diff stat? Hey, about 50 lines of code less. So 50 fewer lines of code and a bunch of problems solved. I think that's a win. I'm kind of tempted to send this now. No, I should put this into the next kernel release and just see if people run into any explosions and where was the patch? There was one hack that Lena put in to increase the that. I think we can get rid of that. And then the RTKit branch. Not the RTKit branch. There is no RTKit branch. This is just MISC. And I don't think there's anything here that cares. No. And so then the only thing is I can just squash everything here because all of this is literally going away. A bunch of RTKit stuff is here that probably should be in the other branch, but and that should just be in there. And then the defer thing goes there. And then that's a squash. Hey, that seems to work. And then we drop all of that. Oh, did I mess that up? Oh, right. I need to undo the mailbox changes there because we don't care about that anymore. And then I need one more change in drivers, sock, Apple, Mailbox kconfig here. Not this one. Yes, in kconfig. I need to just drop the reverse dependency. Probably can put that one in here. Yeah, that works. Okay, it's about the same. It's basically throttling in the same way. And otherwise, around the same scores. Okay, ideas is faster there. I would say that's average. That average is faster. Interestingly, Effect 2D is like slower, but it's also very variable, so. Like Gorod got slower somehow. No, but not the first time though. So maybe it's just the throttling thing. Yeah, it's not being a great test on the air because the throttling is going to throw things off. I would say Jellyfish is at least a little bit faster. IDS also seems to be consistently faster. Hey, Doctor. I killed Mailbox and it somehow worked on the first try. I'm not sure how. What happens if I run glmark like with a tiny screen size? Because I'm not sure if we are limited by like memory bandwidth or stuff like that now, or by submissions. It's a little bit faster. Try putting it in a single core so it doesn't bounce around. Actually, you know what? I'm going to do put the B cores on performance also, and do a test, and then we can revert to the old kernel and do another test, and see if there's more obvious differences. Yeah, this is still alarm. Got over 10,000 there. The thing is, I think to some extent, these are also bad tests just because the Gorod should be, faster than Phong, right? But I think it's because the GPU is also doing its own frequency scaling, which we're not controlling right now, and so there's going to be weird, like performance curves and stuff. Interesting. That one just fails. It's also possible that what we're actually going to see is a reduction in CPU usage, even if the performance doesn't actually increase that much. Because now that the driver has all of the fancy asynchronous stuff that Lean added, it might not matter for these tests. But then, it might still be significantly lower CPU usage. Okay, let's go back and get an old kernel. I'll just reflog it. Where was I? Yes, I know I have a package. I think it was this one here. No, there's no cherry picks there. This one in audio? Oh yeah, this was the last thing I did. And then it went back to Asahi whip. And that never got merged, so that's fine. Met direct dependencies. Oh, because, yeah, I need to turn on Mailbox again. Of course, this is now cooling down a bit, so it's actually going to be skewed in favor of the new test. But hey, reboot isn't messing up now. And some people said that was happening, so there's a good chance that fixed the reboot issues. Okay, let's Let's run that. See what we get. So that was the new Mailbox version. And let's see what we get this time. Looks like a bit slower, but not much. Like less than 1%. Yeah, it looks like basically everything is just a little bit slower. Well, Mailbox makes it slower because Mailbox is doing a bunch of crap we don't need. That's why I'm getting rid of it. And also because it's broken. Yeah, it looks like it's about 1% slower or so. When it's not included, it's just using the driver directly, yeah. And skipping all the Mailbox queuing and all that other stuff. I mean, the reason why I'm doing this is not because I need, like, it's not because I knew it was going to be faster. I mean, I knew it was going to be faster. I'm not sure. I wasn't sure how much impact it was going to have. But the main reason why we're doing this is because we have a bunch of fixes for the Mailbox subsystem queue that it's just getting kind of ridiculous. And it's just problem after problem after problem for no reason. So we are just removing code with this overall, and and it fixes all the problems. So. Yeah, it's moving it into driver sock Apple, but and then it doesn't use the subsystem anymore. And yeah, if this actually fixes the reboot issue, that's already a good reason to do it. Because the whole atomic stuff in Mailbox is really dodgy. Shadow might have gotten faster by more, though it's hard to say if it's just a fluke. Yeah, it looks like a couple percent. Terrain is 2% faster. Maybe a bit more. Conditionals also got 2% faster. To be honest, like the Mailbox maintainer isn't from what, like, he's not one of the painful maintainers. It's more like the subsystem kind of sucks, and getting things fixed through him is hard. I don't know. I mean, we haven't sent most of these fixes, but like at one point we tried to add some. I think Sven tried to send support for the queuing, and he said he didn't like it or something. And I've tried to do some cleanups before, and he disagreed with that. And it's just like he hasn't been a pain as far as getting the driver in the first place, unlike other maintainers. But like the subsystem kind of sucks, and clearly we can't fix it to work for us, so we're just not going to use it. Yeah, 1%-ish faster. It's a single run though, so. But I think that's about right. Yeah, Mailbox is supposed to make it easier for other Mailbox hardware. It never made it easier for ours. It's just being in the way, basically. Okay. I think I'm just going to call it a day here. We are going to... I'm going to do another merge and another compile and make sure it actually works, because I'm probably going to push this to Asahi dev so we can keep testing it, and hopefully it fixes the reboot issues, if nothing else. And then after this gets released to Asahi users, and we know that I didn't majorly regress everything, then I'll send it upstream. Yeah, you can expect a new tag. Actually, I can just make it now if you want. There's a couple other random fixes in here. Actually, let me check that I did fix the bits device tree. There was a Pete state thing hack. Yeah, I think that's all gone. There's one of Linus patches. I think that should be fine. Yeah. I'm daily driving Asahi Linux on my portable laptops, on the stuff I use. That's not my main development workstation. I stopped using that. I had a ThinkPad. I haven't used it in half a year now. It's just my main machine is still this one, because I need the external displays for that. Okay, compiles. I'll just tag it now. That's not the right tag. Are we up to 7 already? I guess. Yeah, the speakers are in proof of concept stage, but I want to get this release out before we move on to that. And then there's the M2 Pro Max bring up stuff that needs some work on. So all those things are kind of getting mixed together right now. Let me push the tag. I think that didn't regress. I think no, this is a fix up that was supposed to be there. GPU should be fine. Miskin mailbox I cleaned up, and device tree I think was probably the p-state thing I didn't push yet. Yeah, okay, so that's an important fix. So 6.27 should be there. Okay, that's... I have both GitHub and GitLab right now. I'm syncing to both. Actually, I need to push the tag to there. We will move to GitLab at some point, but not right now. You can leave it at GitHub for now. I'll make some announcement when I switch to GitLab. So I might still forget to push the tag sometime to GitHub, because GitHub is still the default origin. So yeah, no, don't worry too much about that for now. I'll let you know when it's time to do that. Okay, that's all. I'll see you next time. We'll see what happens. If all the other stuff goes well, maybe M2 bring up at some point next week. We'll see. The Pro Max stuff, which I already have some polls I need to get from people with that, but so I mean, it's already kind of done, but there's some things that need testing and fixing and stuff. So we'll see. We'll see what's up with that. Okay. M2. I meant the M2 Max and well, I have the M2 Pro also, but I'm going to test on the M2 Max first, the laptop, which shouldn't have the DCP problem because it's the laptop. And the M2 Mini stuff, I also need to test. Dana is working on that, on the DCP issues, but it's not ready yet, I think. So anyway, I'll go get some dinner, and I'll see you later.